So remember, if you guys have your notes in by Monday and have completed this exam by Monday, I will give you 5 points extra credit towards this exam, as well as your final exam. So I'll put 5 points to each. The final exam is 15% of your overall grade. So that's a big impact, something that can either really help or hurt your grade. So make sure you're studying. Again, all three of the videos are already posted online for the final exam review, the cumulative review. So it's all there for you if you want to watch them over the weekend or whenever you want. All right, so let's rock and roll with our first one. All of these, you can graph them. So personal preference. When I look at this, some vocabulary, some things that we struggle with, when we talk about something that's bounded, bounded means it's going to be shaded inside the conic, where unbounded means it's shaded outside the conic, whatever it is. So in this case, we're going to be working with an ellipse. I know it's an ellipse because it's a plus in between. So again, if we have an ellipse and it's shaded here, we would say it's bounded. If it was shaded here all around it, then we would say that that is unbounded. Unbounded. Okay. So for this, I also know that it's going to be a dashed line. So when we talk about a dashed line, we say that the boundary is not included. So in this case, the boundary, it's so hard because there's bounded and then we use boundary. So in this case, the boundary is not included. And when we talk about that boundary being not included, that means that if I have a point on this line, so if I have a point here on it, it's not going to be part of it. Now, if it was solid and the boundary was included, then that point would be part of your solution. Okay, so this one right here, let's just go ahead and do a quick little sketch by hand. So this is going to be my a squared. It's the larger one for my ellipse. So that means that a is equal to 4. This is my b squared. So that means that b is going to be 2. I know that my center here is going to be at, here's my h, here's my k. Be careful because a lot of times you guys want to go ahead and just do it in order and write -2, 3, -2, 3. That is not correct because the h has to come first. So it should be 3, -2. Be careful about that. It's probably one of the most common mistakes. So I know it can't be either one of those because that doesn't match the center. So we need to figure out then which one of these, is it going to be bounded or unbounded? So quickly sketching this, I'm going to go to 1, 2, 3, down 1, 2. So 3, -2, there's my center. I know that, sorry, along my y values. So since my 4 is under my y, I'm going to go up 1, 2, 3, 4. I'm going to go down 4. I'm going to go along the x-axis direction, left and right, 2, because my b value is 2. So I'm going to go 2 to the right and 2 to the left, and I have my dashed ellipse. All right, so now I need to figure out, well, where's the shading going to be for that? An easy test point when I have a center here, when I have a value that has the center, that's a good test point. Or again, I can always use my 0, 0. Remember, when I have a center, though, if my center is at 3, -2, and I use that as my test point, then it's going to be -2 plus 2 squared all over 16. Plus mine is going to be 3 minus 3 squared all over 4 is less than 1. So when I use that center, it's always going to end up giving me a value of 0 here and 0 here. So when I add it, it's really going to just be a 0 less than 1. And is that true or false? Well, 0 is not going to be, or sorry, 0 is going to be less than 1. This is true. This is true. So if it's true, then you shade it. So where it's true is going to be shaded. Where it's true, it's going to be shaded. So this part is true. This point is true. So that means everything in here is shaded. Everything in here is shaded. So since it's on the inside, we say that it is bounded. It is bounded. It's inside, so it's bounded. So my answer for this one is going to be right here. I'm gonna take a sip. If you guys have questions, feel free to put them in the chat. All right, this one's describing features. So again, you could graph this. These are a little bit difficult because when you graph them, they don't automatically put the focus in there for you. So you still have to do work by hand. So these are ones that I like to just go ahead, sketch them by hand real quick. So we know, what are we working with? We're working with a hyperbola because it's a minus. I know from my values here, what's being squared. This is going to be my A, so A 96 is being squared, so A is going to be 96. Here is going to tell me that my B is going to be 40. My center for this is going to be at 0, 0 because there's nothing with my X or my Y values. That makes it easy to work with, right? So let's go ahead and just do a quick little sketch. So I have my center. My A is under my Y value, so that means I'm going to go up 96 and I'm going to go down 96. So just sketching it. I don't need to go 96 marks. Okay, so since my Y comes first, I know that this is going to be where my vertices are going to be. So that's going to tell me then that my hyperbolas are going to be opening up and down, up and down, up and down. And the other piece of this is I know my B, so I know it's going to be negative 40 and 40. So this box right here, these are my co-vertices. This box helps me with my asymptotes and identifying them, or you can have the formula, whatever you want, but I don't really need it to figure out anything else in here. So I know then it talks about my focus, so I need to figure out what my focus is. So to find my focus, we need C. So remember, if this is a minus here, then when I find my C value, I use the plus sign, I use addition. So C squared is going to equal then A squared plus B squared. Remember, when we have an ellipse and it's a plus here, then I use a minus here. So I know my A, I know my B, I plug it in and I get C squared is going to equal my 96 squared plus my 40 squared. I plug that in my calculator. I get C squared is going to be 10,816. So again, I just plug that in a calculator. And then I end up with C is going to be 104. That means that I'm going to go from my vertex, I'm going to go up to 104. So this is going to be at 104, and I'm going to go down to negative 104. So these points, this point right here, then is going to be 0, 104. This is going to be here then at 0, negative 104. Why did I make sure to write it out like that? Because right here it says that you have a focus at 104, 0. This is not correct because that would be saying you're on your x-axis. And remember, the focus has to be inside the parabola. So it always helps to sketch it, because even though you come up with that value of 104, sometimes you guys think, oh, 104, it's there, that's my answer choice. And it's not the case. So again, sketch your graph so you can get that visual and not make those little mistakes. So it says that at 0, negative 96, 0, negative 96 is this point right here, is going to be focus. No, that's actually our vertex. That's a vertex there. I have a vertex at negative 40, 0 right here. No, that's actually a co-vertice. So it's one of your co-vertices. I have a vertex at 0, 96. Yes, that is true. And my center here was at 0, 0. That is true. So it was the last two that were going to be correct. So again, this was incorrect. It's actually at 0, 104. So they were switched. So be careful. All right, next one. We saw one like this yesterday, talking about earthquakes and they're being modeled. So an earthquake happens at 20 kilometers east, 14 kilometers north of the center of Columbia, North Carolina. So the quake is felt 25 miles away. That's where this is coming from. So this is where the center of the quake is, and this is that radius squared. Remember, r squared, that's my 25 squared. A couple of days later, there's another earthquake that can be that occurred at 8 kilometers west, 3 kilometers north, and could be felt 14 miles away. So there's where the center of that earthquake is, and this is going to be my r squared, that 14 squared. So that's that radius that people that felt it. So it says if Columbia is located at 0, 0 on a coordinate plane, the system of the inequalities represents the scenario. So they gave us the actual system. This is great because all we got to do is graph it. So first thing I would do is I'm going to go ahead and I would put these in my Desmos. Okay, then it's asking you which location relative to Columbia felt both earthquakes. And we talked about this yesterday where this represents my directions. They're all in a directional coordinate. So I have my north, east, south, and west, right? Well, if I'm going to be doing anything that's going to the north, then if I look at this as my x-axis, if I'm going north, then that's going to be a positive value. If I'm going east, that's a positive value. When I go south, then we're talking about a negative value. And when I go west, I'm talking about a negative value. So each of these directional pieces of information can be written as a coordinate, and that's what you're looking for to be a solution to. So when I look here, if I go 4 west, that's telling me I'm going -4. And then if I go 12 south, I'm going -12. So this would be -6, and north would be a +4. If I'm going east, it's positive. So I go 2 east is +2, and 10 north is +10. And here, if I go 6 east, I'm going +6, and I go 8 north, that's going to be a +8. So all I'm looking for are going to be these coordinates. These are going to be, I want one of these to be a solution for this system here. So I'm going to go ahead, I'll share my screen. I already put them in. So let's go ahead and look at that. So you can see I already have the equations in. So I'm going to hide that piece, and I'm going to actually add this up to share. Let's see if I could scooch that over. And here we go. So I'm looking to see where my points are going to line up. So I'm looking for -4. If I'm at -4, the first coordinate is -4, -12. So it's going to be down over here. The counting by ones. So I can see I'm not in either there. And it's looking to see where they were both felt. So I'm looking to be in this region where the 2 circles overlap. That's going to be where they felt both earthquakes. So it's not going to be my first option. I go to my second one. I go to -6, +4. So -6, +4 is here. So only one of the earthquakes felt it. And when I go to 210, so if I go to 210, can you guys see the mouse on there? I just assumed you could, but I actually don't know. Okay, cool. So when I go to 210, you can see for 210 that is where they both overlap. So that would be my actual solution is here at 210 because that's in the green and in the blue circle. So it's felt by both. If I wanted to check my last one and I'm at 6.8, so 6.8 would be right here, which is again just in the blue. So you can see then my one option. Desmos is really going to be great for this test. All right. And then my very last one, what type of conic is represented here. So remember, we have it where we have no xy and where we have an xy. So if I have no xy term, then all we need to look at was our a and our c value. If we have some bxy term, then that's when we're going to use our b squared minus 4ac. So in this case, we have a bxy term. So here's my a, here's my b, here's my c. I plug them in. I end up with negative, oh, sorry, it's b squared. It's going to be 10 squared minus 4 times my a, which is -5, times my c, which is -5. So I end up with 100 minus, A negative and a negative is going to make that a positive. 4 times 5 is 20. And then I'm going to have 20 times a negative 5 is going to make that a negative 100, which is a value of 0. Since it's a value of 0, it's going to be a parabola. It's going to be a parabola. If you guys have any questions, please reach out to me, let me know. Otherwise, good luck if you take the test over the weekend. Otherwise, I have one more set of questions that I'm going to do on Monday. This all needs to be done by Monday at 11:59 p.m. So if you want to wait to take the test on Monday after we do our lesson, you're totally fine. So you just need to make sure notes get in and the test is taken by Monday. So you guys are go. So it doesn't need to be done by Sunday night. You have until 11:59 Monday night. So as long as it turned in anytime on Monday, you'll be good to go. You're welcome. You have a wonderful day. Have a good weekend, you guys. Take care. Bye.